This visualization represents the operational reality of family court. It is a highly fragmented, adversarial environment where competing interests clash within a confined legal space. A single case involves dozens of actors, attorneys, guardians ad litem, therapists, and mediators. All generate and interpret sensitive data from different and often conflicting professional vantage points. This network diagram maps over 30 distinct professional functions interacting on a case. Modeling these frequently adversarial behaviors in software requires more than a simple messaging interface. The standard software response is to take a closed application and layer role-based access control, or RBAC, over the top. This restricts who can see specific data fields based on their login. Treating adversarial roles as a single monolithic system, separated only by access permissions, creates a significant functional gap. It forces a single, generalized AI behavior onto professionals who are legally and ethically required to maintain distinct procedural boundaries. These architectures illustrate the difference. The model on the left shows a traditional gateway funneling every user into one monolithic node. The model on the right shows a network of independent agent nodes. This utilizes the role primitive, developer building block, rather than a simple user tag. These role primitives operate with dedicated logic and isolated data contexts. Achieving this decoupling requires the Model Context Protocol, or MCP, to handle communication. Building vertical AI for these sectors involves moving away from closed apps in favor of purpose-built, role-based SDKs. This matrix maps the current structure of the legal tech and agent AI markets across 3 distinct tiers. Tier 1 consists of general agent SDKs, such as Crew AI and the Microsoft Agent Framework. These Tier 1 platforms provide raw orchestration power, supporting parallel execution and hierarchical agent management. However, Tier 1 lacks a pre-built, domain-safe taxonomy. Developers must build every professional safety rail and legal protocol from a blank slate. Tier 2 covers closed corporate legal platforms like Harvey. Tier 3 includes closed consumer applications for co-parenting and scheduling, such as OurFamilyWizard and Cozi. Tiers 2 and 3 share a common limitation. They do not offer a third-party developer surface, or API, for building custom, role-specific tools. If we remove the generic frameworks on the left and the closed products on the right, we find a structural void in the market. A white space exists for a domain-specific SDK layer that sits between raw LLM compute and closed end-user applications. This architecture diagram for CoTrackPro serves as a reference for how to fill this market gap. The top levels use a standard stack, React and Vite frontend flowing into a Node and Express backend supported by AWS. At the base, the system connects to the raw compute layer via the Anthropic Claude API. There is a specific architectural gap between that standard web backend and the raw LLM compute. An MCP server acts as the critical intermediary component, bridging that gap. Without this specialized routing layer, standard web stack relies on the same generic LLM outputs as any other application, limiting its ability to enforce role-specific logic at the protocol level. Zooming into the MCP server node reveals 35 distinct submodules operating within it. The MCP server acts as a gateway that exposes 35 professional roles as discrete executable tools. We can examine the guardian ad litem module as a specific example of a role primitive. This primitive contains instructions and dedicated sub-agents engineered specifically for the duties and constraints of that role. It also incorporates inter-agent handoff rules, governing exactly how the guardian ad litem node interacts with other roles like attorneys or therapists. Generic frameworks typically require developers to build these behavioral constraints and routing rules from scratch for every deployment. Encoding domain logic at the protocol level effectively transforms a static user profile into an independent software agent. This schematic compares a thin API wrapper architecture on the left against a protocol-layered architecture on the right. An engineering firm can technically spin up a thin role layer on a Tier 1 SDK in 8 to 12 weeks. However, building directly on proprietary orchestration patterns often leads to long-term protocol lock-in. Bypassing an independent MCP layer exposes core business logic to shifts in the underlying LLM models and and API deprecations. MCP adoption provides model flexibility, allowing developers to switch providers while maintaining the same standardized interface for tools and roles. Choosing to skip the protocol layer creates long-term technical stability or a shorter initial deployment window. This diagram visualizes the actual software moat in vertical AI, focusing on the proprietary domain logic protecting the central data core. The first pillar is the codified taxonomy of 35 distinct professional roles. The second pillar is the set of trauma-informed architectural guardrails hard-coded into the inter-agent communications. The third pillar is the set of court admissibility constraints baked into the output generation layer. Replicating this triad of domain discipline, taxonomy, safety guardrails, and output constraints requires a depth of legal integration that goes significantly beyond basic prompt engineering. Building an open ecosystem changes the developer's objective from creating a standalone tool to establishing an industry standard. Standardizing these professional roles as first-class primitives allows an architect to influence how future integrations are built across the industry. The MCP layer provides the universal delivery mechanism required for these primitives to function. In vertical AI, the advantage belongs to the architect who provides the structured foundational layer for the rest of the market.